Welcome to my course, Game Development Basics, Week 4, Lesson 5, Creating a Light Puzzle. In this lesson, we're going to create a puzzle for our project. And the point of this puzzle will be to unlock the doors once the player flips the breaker. And in the last video, we were able to set up our circuit breaker so that it calls this event dispatcher flip breaker off, which will eventually unlock the gate, and it also turns all the lights off in our house. We also set it up so that it closes and locks both the doors to this house. So the doors will be locked, and we want to create a way that the player can unlock the doors by solving a puzzle. Now, I'm going to create my puzzle one way, but there's no requirement to do it exactly the same way that I do. This is a good chance for you to get creative and try your own things and branch out a little bit. I do want to include a few requirements though. And here's the requirements for this challenge. We want to make a puzzle that uses our interactable interface and also makes use of event dispatchers. The puzzle should require a sequence of at least 3 separate actions by the player. And completing the puzzle must unlock the door. So whatever the puzzle is that you design, the end result is that the door becomes unlocked. And if the player gets the combination wrong, it must reset the puzzle. And once you've met all these requirements, test for bugs to make sure that you didn't overlook something. So given these requirements, if you'd like to attempt the puzzle on your own, you can pause the video now and give it a shot. Otherwise, I'll walk you through my implementation. And here's just a quick diagram of how I want my puzzle to work. I'm going to have 3 different lights, and they're all going to have a variable of the number of that light. And then I want to have both of the doors on my house unlock when the puzzle is correct. Now, an event handler can only bound to one actor. So because we have 3 lights and 2 doors, there's no real clean way to implement this. And I'm sure if you got creative, you could probably figure out a way to do this. However, I find that in cases like this, it's usually easiest to create a new actor that handles the puzzle. And in this actor, I'm going to create 2 variables, current combination and final combination. Then I'm going to create 3 methods, increment combination, reset combination, and unlock doors. When the player interacts with one of the lights, I want the puzzle handler to check if it's the current light in the sequence. If it is, we'll increment the combination, and if it's not, we'll reset the combination and the lights. This means the player will need to interact with them in order to continue to increment the combination. Once the final combination number is met, we'll unlock the doors. And with this knowledge, you now have the ability to create this puzzle on your own. However, I know this might be a little overwhelming at this stage of the course. So if you want to try to do this on your own, you can pause the video now using this diagram, or you can continue to watch and I'll show you how I would implement it. So here I am back in my project, and the first thing I want to do is create my puzzle handler. So I'm going to create a new blueprint class, and this can be an actor, and we'll call this BP Puzzle Handler. And let's open that up. And as I said, in our puzzle handler, we want 2 variables, and they're both going to be integers. The first one is going to be called current combination, and the second one is going to be called final combination. I also want to create 3 new custom events. The first one is going to be called increment combination. The second one will be called reset puzzle, and the third one will be called unlock doors. Now I want to create my light puzzle actor. So I'm going to create a new blueprint, and it's going to be an actor, and this will be called BP Light Puzzle. And I want a visual representation of this actor for my player. So I'm going to add a sphere. And I'll bring the sphere up just so that it'll be touching the ground. Let's create 3 of these in our level so that we can play test this. And here on my light puzzle, I'm going to create an event dispatcher, and I'm going to call it light interaction. And I also want to implement my interactable interface. And let's implement this start interaction event. And this is going to be real simple. When we interact with this actor, we want to just call the light interaction event. On my light puzzle, I want to create a variable called light number, and this will be an integer. And this light number, we want it to be different for each actor that's in our level. So we want to create this as an instance editable variable. And now these three in our level, we can change the light number. So I'm going to call this one number 1, this one will be number 2, and this one will be number 3. And what we want is when we interact with the first one, it'll be the first one in our sequence. So now we want the puzzle handler to be aware of that interaction. We can do that by binding it to this dispatcher. But the issue is we have 3 of these in our level, and we can only bind to the event of one actor at a time. So in our puzzle handler, I actually want to create a new custom event, and this is going to be called bind to light. And I want to call this right off begin play. So what we want to do is we want to get all actors, and we want to get all of the light puzzle actors. And we'll take a for each loop, and we want to check that the current combination number is equal to the light number. And if the light number is equal to the current combination number, we want to bind to the light interaction. And here we want to create another custom event. And this is going to be called check combination. And what I want to do is I want to check if the light number is equal to the final combination number. If it is, this will tell me it's the final light in my sequence, and then we can open the doors. So instead of dragging off of here, what I can actually do is go back to my light puzzle and check my event dispatcher, and I can add an input. And that input can be an integer, and we can connect our light number to that integer. And now we'll see that here our new custom event now has that parameter on there. And we can check if these are equal. And if they are, we can call unlock doors. And if they're not, we'll call increment combination. And neither of these is programmed yet, but we can do that in a minute. But real quick, let's recap what we've done so far. We created our light puzzle actor, and we set up our interactable interface on this actor. When we do interact with this actor, we're going to call an event dispatcher called light interaction, and it'll pass in the light number of this actor. Our puzzle handler on begin play will call bind to light, which will get all of the actors of light puzzle. It will find the one that has the light number the same as the current combination. If it does, we're going to bind the light interaction event to check combination. Check combination will verify that the light number that we passed in with this event dispatcher is equal to final combination. If it is, we will unlock the doors, and if it isn't, we'll increment the combination to the next actor. For increment combination, we want to get our current combination and increment it. And then we want to bind to the next light. And for our unlock doors, we want to be able to unlock all of the doors at once. So this is another place where we could use an event dispatcher. And actually this means we don't even need this custom event. We can delete it. And then over here, we can create an event dispatcher called puzzle complete. And we can just call this right off of the true. Now here in BP door, we can get our puzzle handler, and we can bind to puzzle complete and create a new custom event called unlock doors that just sets locked to false. And for testing purposes, I have my door locked boolean set to true. Just to give me some visual representation, here in puzzle handler, after we increment the combination, I want to do a print string, and we'll just print the new combination number. Hey, this is Jim from the future, and I realized when I was editing this video that I forgot one important piece, and that's that our puzzle handler actually needs to be in our level in order for it to work. So make sure you take one of these actors and drag it into the level, otherwise nothing is going to work the way you intend it to. So when I interact with the first puzzle, I should print 2, print 3, and then I won't print anything because we don't call that function, and we'll just unlock the door. So there I printed 2, I printed 3, and here my door is locked, so when I interact with the last one, the door should now be unlocked. So far this puzzle is working great. We have our 3 light puzzle actors, and each one of them has its own number. If we interact with them in the correct order, it unlocks the door. The next step is getting it so that if the puzzle combination is wrong, it's going to reset the puzzle. And so when we interact with our light, we want to first check if it's the right number. And only if it is, should we call this light interaction event dispatcher. So I'm going to create a new function called check combination. And in here, I want to get my puzzle handler. And I want to get the current combination. And we'll check, is the current combination equal to the light number? If it is, then we want to call light interaction. And we'll pass in light number. And if it isn't, then we can just take a reference off the same actor and we can call reset puzzle. Back on our puzzle handler, we need to set up what the reset puzzle does. And what do we want it to do? The first thing we want to do is set our current combination back to the starting value, which in our case, we chose 1. Then we want to bind back to that first light again. And let's put a little print here. That way we know when the puzzle is resetting. And one thing I forgot here, on our interaction, we want to change this to not call light interaction. We actually want it to check combination. So now if I interact with the first one, it'll print 2. But if I interact with it again, it tells me that the puzzle has been reset. If I interact with the first one and press 2, and then this one, it'll reset the puzzle. And anytime I select the wrong one, I'll get the puzzle reset message, which means only if I do them in the correct order will it unlock the door. The last step of programming is to test for bugs. So we want to try everything that we can think of that the player may accidentally do that could break this puzzle. So try all the different sequences, try interacting with the door in between each press, and make sure that there's no unintended bugs. And once we have everything working, let's remove all of our print strings. And I actually want to give a visual representation to our player when the correct combination has been chosen. And I'll do that by first creating a material. And I already have this glow material that I made, and there's a material instance called glow. So I can put that glow onto my lights. So here, when the player gets the correct combination, we want to make the light light up. So after this, we can type set scalar. Here we have set scalar parameter value on materials, and it says it's our sphere. And in our material instance, we have a parameter value called intensity. So we can type that parameter name in here and set it to something like 10 to show that the light is getting brighter. And now when I interact with the correct light, the light should turn brighter. But they're all pretty bright to start, so let's start by taking the same 2 nodes and copying them, and then on event begin play, let's set that value to something like 0.1. Now they're much more dim, and when I interact, it turns on like a light bulb. And we can actually make this its own function called dim light. And that will dim the light on begin play. When we interact with the wrong light, we want all of the other lights to turn back off. So in our puzzle handler, let's create a new event dispatcher called lights out, and we'll call this when we reset the puzzle. So back in our light puzzle, on event begin play, after we dim the light, we'll get our puzzle handler, and we want to bind to lights out. Create a new custom event, and on here we can just call dim light. Now if we interact with the correct one, it will turn on, but if we interact with the incorrect one, all of them will turn back off. And now our puzzle is working in accordance with all of the requirements. And I know this might have been a lot to digest, so I'm just going to do one more quick walkthrough of everything we did to make sure that you understand. We have an actor in our level called Puzzle Handler. On Begin Play, we want to call Bind to Light. And what Bind to Light will do is it will get all of our light puzzle actors, it will check their light number. If their light number is equal to our current combination, we're going to bind an event on the light puzzle actor's light interaction event. Which means when we interact with the correct light, we'll check the combination. If it's the final combination, we'll call puzzle complete. And if it's not, we'll call increment combination. Increment combination will take our current combination, add one to it, and then call bind to light, which will bind to the next light in the sequence. In our light puzzle actor, we implemented our interactable interface. And when we interact with the light, we're going to call check combination. Check combination will get the puzzle handler actor and check if the current combination is equal to this light's number. If it is, we already know we called the light interaction dispatcher, and we also set it up so that the light will get much brighter. If it's not the correct actor, we're going to call reset puzzle on our puzzle handler. Reset puzzle will set the current combination back to 1 or whatever your start in the sequence is, and then we'll bind to light again to make sure that we're binding back to the correct light. We're also going to call a lights out event dispatcher. And in our light puzzle, we're binding that lights out event to dim light, which will dim the light back to normal if the player gets the incorrect combination. And the last thing to cover is when we did call this puzzle complete event dispatcher, our doors had bound to that a function called unlock doors, which just unlocks the doors in the level. We don't want the player to be able to start the light puzzle until the breaker is tripped, because at that point the doors are locked and the player is locked in. If they can interact with it before then actually the puzzle could be completed and then they go flip the breaker and then they're locked in, and it's just going to create a big mess of things. So the first thing I did is on my interact, I created this branch and I created a new variable called activated. And only if it's activated can we actually interact with these light puzzles. And here in Begin Play, I'm now getting the circuit breaker and I'm checking that the breaker number of that circuit breaker matches this instance editable variable, also called breaker number. And if it does, we want to bind an event to flip breaker. And that event is going to be called activate. I set my Boolean activated to true, and then I bind to lights out on my puzzle handler. So this last bit of code was already here. Really, I just threw in this extra piece in the middle as a check that we're only going to be able to start this puzzle once the player has tripped the breaker in our house 2. Also in my dim light, I took this parameter value of intensity and I added it as an input to this function so that in the beginning we can set it to 0. So our spheres are going to be pure black. And then here, when we're triggering lights out, we'll set them back to 0.1. And then here, when we activate it, we're going to set it to 0.1 so that you're just slightly glowing for the player. And we'll dim it back to 0.1 if they get the wrong combination. So this just gives the player a little bit more feedback of what's going on. They may discover these black spheres in the house, not really know what they are. They go flip the breaker. Now they're locked in the house, but suddenly those little spheres are glowing a little bit. And this could give them some indication that now they may need to interact with them. I also put my 3 spheres inside the house. So when the player gets inside this house, if they turn their flashlight on, they may notice them and not really understand what they are. They just see these little black spheres on the ground. But once they flip the breaker and they go back down and realize that they're locked in, now those spheres are glowing, which would give them some indication that they need to interact with them. And now they can get out. So I think that's just a little bit more complete. I think that pretty much wraps up this puzzle. And the way that I did it isn't necessarily the way that you need to do it. There's many ways to make this puzzle work for your game, and also arguably this may not be the most efficient way to implement this puzzle. Really what I was trying to do is create a scenario where you could get comfortable using event dispatchers, get comfortable using your Interact interface, but I'd be very interested to see what kind of creative implementations you came up with, or if you came up with a more efficient way to create this puzzle. If you have any tips, please leave them in the comments. I'm sure other people would be more than happy to get some extra help on this one. And I know this was arguably one of the most complex videos to date, so if you struggled a little bit with this one, this should be about as difficult as it gets for this week. So thanks for sticking through it, and I hope you had fun. I hope this was a little bit more challenging for you, and I'm really excited to see you in the next video.